Okay, today's lesson we're going to do sums and product of functions. So our learning intention is to understand the skill of sketching the graph when two functions are added together or when they're multiplied together. So some of our success criteria include being able to algebraically add or subtract functions, algebraically multiply functions together, complete a table of values and plot points is one option, and sketch the resulting function. So let's do some examples. Okay. Here we want to sketch the function of f of x plus g of x. If f of x is x squared plus 2x and g of x equals 1 minus 2x. So we're going to add, let's do the algebraic method. And all we're going to do is add f of x plus g of x. Okay, so if we were to do x squared plus 2x, that's your f of x. And we're going to add 1 minus 2x. Okay, combine like terms, we get x squared, 2x minus 2x cancel each other's out, plus 1. Yeah, so I create a parabola of x squared plus 1. So yeah. Okay, so the normal x squared translated up the y-axis by 1. Something like that. Okay, and so basically what I've done is we've added the two functions together, so a quadratic with a linear equation, and we've produced another quadratic out of this, and it's just the normal parabola translated up 1 unit over the y-axis. Let's look at that using a table of values. Okay. Okay. Let's start with x on the top. I'm going to have f of x, which was x squared plus 2x. And I've got g of x, which is 1 minus 2x. And then we've got the sum of them. I'll just do a couple of points. Yep. Let's say -2, -1, 0, 1, 2, and 3. Okay. If I'm using f of x, so 0 squared plus 2 lots of 0 is just 0. Yep. 1 plus 2 is 3. 4 plus 4. Yep. 4 plus 4 is 8. 9 plus 6 is 15. That becomes 1 plus -2, which is -1. And this will become, so positive 4 minus 4 would be 0. Okay. And so I'll do it with another pen. I'm going to plug in these values for this linear equation. So 1 minus 0 is 1. 1 minus 2 is -1. That's 4. 1 minus 4 is -3. 1 minus 6 is -5. And then that becomes a positive 2, becomes 1 plus 2 is 3, becomes a positive 4, 5. Okay. And now what we're going to do is add the two coordinates. So we have 5, negative 1 plus 3 is 2, 1, 2, 5, and 10. Now if we use these this equation, what we found, we should get these results. So 0 squared plus 1, 1 squared is 1, plus 1 is 2, 2 squared is 4, plus 1 is 5, and so we get this parabola. Okay, so the function of f of x plus g of x when f of x equals x squared plus 2x and g of x equals 1 minus 2x is the parabola x squared plus 1. Let's do another example. We've got, we're going to sketch these two functions. So we've got f of x plus g of x, f of x equals negative x cubed plus 1, x squared minus 2x plus 1 equals g of x. So we're going to add them together. So f of x is negative x cubed plus 1, and we're going to add g of x, which is x squared minus 2x plus 1. Alright, so I don't have any other x cubes. I have a positive x squared, I have a negative 2x, and 1 plus 1 is 2. Okay. Now I'm going to factorize by grouping in pairs. So I'll take out a negative x squared. I need to times that by a negative 1 to make it positive. Take out this, negative 1. So I've got negative x squared minus plus 2 and an x minus 1. Okay, so then if I wanted to apply the null factor, so this is equal to 0, using the null factor rule, we've got x minus 1 equals 0, so x has to equal 1, and we've got x squared plus 2 equals 0, x squared equals negative 2, so there's no other roots apart from x equals 1. Okay. Okay, so x equals 1 is here. Let's find our y-intercepts. Okay, so that's going to be 2, that's 0, minus 1, so negative 2 times negative is 2. So 0, 2, negative 2, negative, yep. Okay, so it's a negative cubic, so it would look something like that. Okay, and once again you could do the tables and start plotting points as well. Okay, let's do example 3. Let's do a product. Okay, now we have y equals f of x times g of x. Okay, so f of x times g of x means we've got x squared times 1 minus x. Okay, so we have x squared minus x cubed. Okay, and we want to actually sketch that. So if we want to have our x-intercepts, So that's going to be at 1 and 0, a double root at 0. And our y-intercept is also 0. Because that would be 0 times 0, just equals 0. Okay. So we have another cubic. We have intercept at 0, at 1. So it's a double. Okay. I will just test some points. So let's say if when x equals 5. So we get a negative value. We got 5 squared minus 5 cubed. Yep. So negative value. So we've got something that looks, remember that's a double root. Something that looks like that. And if we want, we can use our table of values again. So that's x, f of x, our g of x, and our f of x times g of x. Okay. So that was x squared, and this is 1 minus x. Okay. So we'll do values of minus 2, minus 1, 0, 1, 2, 3, okay, 4. Okay, so this will still be 0, 1, 4, 9, 16, 1, and 4, because it's just x squared, it's a parabola. And so this is 1 minus 0 is 1, 1 minus 1 is 0, 1 minus 2 is minus 1, 3 minus 2 minus 3, plus 1 becomes 2. Yeah. Okay, now we're just going to multiply those together. So 4 times 3 is 12. 1 times 2 is 2. 0. 0. 4 times negative 1 is negative 4. 9 times negative 18. And negative 48. And as you can see, at 0 we have 0, 1 we have 0, at half we might, would have some value up here. Yeah. This side we have all positives, so that will increase, and then this side we have all negatives. Okay. Okay, so example 4, we've got, we're going to sketch f of x equals y equals f of x times g of x. If f of x equals x plus 4, and g of x equals x squared minus gx 6x plus 5. So we're going to multiply them together. Okay. So before I start to expand out and get a cubic, what I'm actually going to do is going to factorize this last part. So it becomes positive 5, so 2 negatives, so x minus 5, x minus 1. Okay. So here we have our x-intercepts at negative 4, positive 5, and positive 1. Okay, and obviously factorizing first helps with noticing the x-intercepts rather than going towards expanding. Yeah. So our y-intercept happens when x equals 0, so that's 4 times -5, so that's -20 times -1, which is positive, so it equals at 20. Okay, so what we get, we've got something here at 20, -4, we've got 5, and we've got 1. Okay, so we want to figure out if it goes like that, or if it goes, no, it has to go, because in order for it to cut that axis, it needs to go something like this. Yeah. And so we get that. Okay. And that's sketching when adding or multiplying functions together. Okay, thank you.